Hello and welcome to tutorial 13. Alright, hope you had a great time solving challenge number 11 at the end of my previous tutorial, which was tutorial 12. Now this was the challenge that was posed to you. So you had a robot that was supposed to start here and basically go through all the different stations and stop once the robot reached the red station. Alright, so I gave you some hints. I asked you to look at the angles here, one station to another. That was 90 degrees. If you join the line all the way here, okay. And if you observe the pattern, the way they're all facing each other, 90 degrees to each other, you realize this would be the first station, second, third. Then it will bounce here, go here, 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 and then here, here, and then finally reaches the red, stops. Okay. So my overall condition would be, if it does not see the red, carry on going forward or turning when you see the respective colors, whether it's blue or green. And then for green, it would need to turn right, because when you're hitting the green here, you need to turn right. When you're hitting the green, you're turning right. When you're hitting the green, you're turning right. So basically, if you really observe, every time you hit green, you got to turn right. Similarly, when you hit the blue, you got to turn left. So every time you hit the blue station, you're basically turning left. Okay. And you got to use your down eye. All right, you're always using your down eye, because you're basically looking out for the green mat at the bottom, or the green box at the bottom. Okay, because it's the mat or the box, I'm not sure what that is, but that is what is basically 90 degrees to each other. Okay, so looking at this thing down here, okay, your top eye doesn't really help you much. You got to look at the bottom eye. All right, now, so this is my program. Really simple. Okay, and I couldn't find out any simpler way to get this done. If you got a simpler way, please send me a comment. All right, so while it doesn't detect the red, okay, then it carries on this logical movement where it sees the green, it turns right, and if not, if it sees the blue, it will turn left. Else, which means if it's in the white, it drives forward. So every time it's in the white, it will keep on driving forward unless it's green or blue. And eventually, if it sees the red, it will exit the while loop. It will just stop driving. Cool. So let's see how this works out. Okay. Here you go. Bang. Goes right. Hit left. Hits the blue. Turns left. Cool. All right. Green, turn right. Come on, we're almost there. And then finally, red exits the while loop, stops driving. Cool. So if you got it right, congratulations again. Okay, so let's move on to something new. Okay, so here I'm going to talk about location sensing. Okay, we're finally going to use some of the data that's actually down here in this row. So we've always seen data, but I've never actually talked about it. And how you use location sensing is basically you look at each square, okay, as a location, or as a set of coordinates on a Cartesian plane. So if you studied coordinate geometry, which if you guys are in year 6 or year 7, you'd probably know about how to actually locate a certain point using the x and y axis. So if this middle line, so if you look at this middle line, that's like the y axis. This is like the x-axis, and the location that the robot is now presently is negative 900 x, negative 900 for y, because if that's my center, so it's negative 200, 400, 600, negative 800, negative 900, so that's x. Then it goes down, negative 200, 400, 600, 800, and the center of the robot will be negative 9. So the robot is now sitting at negative 900 x, negative 900 y. So that's the location of the robot. If I was to be here, okay, then that would be negative 900 x and probably 900 y, because that's positive. So imagine that's the origin. All right, so that's positive y, negative x, positive x. All right, now I'm going to teach you how to use position sensing to basically command your robot to stop where you want it to, okay, based on what coordinate is at that location. So let's say I wanted my robot to turn right, drive all the way until it came somewhere here. So I'm basically gonna state the position and then use a while loop, okay, to specify when this should stop. So I'm gonna bring in my while loop. Let's have a turn right. Okay, so the robot will start by turning right 90 degrees. I want it to stop when it reaches about 500 x value 500 and y value of 500, somewhere around here. I want it to stop. So how do I do that? Turn right. So while, so again, this is where you get your position sensing block. So go to position sensing. So there you go, location sensing. I'm going to drag my position sensing block, duplicate it again, we'll change that to y. Okay, so I've got my x position and my y position. Okay, then I'm going to go to operators and grab a and. Okay, and operator block. What you're doing here, basically, you're basically having two inequalities. So I'm going to say while position x is less than 500 and y is less than 500, carry on driving forward. Forward is in after you turn 45 degrees. So I'm going to get my inequalities. So less than, here you go. And then duplicate that again. There you go. So let's put this in here. Put this in here. Okay, so while position x is less than 500 and position y is less than 500, I want the robot to carry on driving forward. All right. So you can turn right and drive forward until it's about 500, 500. So x 500, y 500. So while this is happening, okay, I want it to drive forward and draw a line. Let's see how this goes. So move robot pen down, if you still remember. Send the looks. Robot pen down. And then set color to, let's select blue. And then drive forward. Sorry, drive forward down here. So it's gonna move the pen down, set the color to blue, and then draw a line until it reaches somewhere here, 500, 500. So this is 0, 0. This 500 would be here. 500 for y would be here. So it should stop somewhere here. All right. So let's see how this works out. Okay. Let me just try and set the speed a bit higher. Set drive velocity to 80%. Okay. Okay. Here you go. Oh, what's happening? Oops, I did a mistake. I know where I went wrong. So basically it should be not 90 degrees, 45 degrees. It's never going to hit y 500 down here because this is all negative for y. It should be 45. Let's try this again. Okay, there you go. Okay, it's going. It should stop somewhere here. No, it's not. It's not. What's happening again? Oh, I know what's happened. So while the x and y value is less than 500, it will draw the line. If this condition is not met, I haven't put an action there. So if it's not met, what happens? It's nothing there. So I've got to stop moving. Come on, I've got to stop driving. Now this should work. Come on, you got to work now. Okay, let's do it again. See, I'm making mistakes and we're all learning through mistakes. Let's go. Okay, it's going. Let's look from the top view. It should stop here. Exactly. All right, so this is perfect. Okay, so I didn't have that condition, which is what would happen once it goes out of the while loop. There was nothing there. Now that I put it in, it basically stops driving once it's less than 500 for x and y. All right, so simple enough. All right, so coordinate geometry, Cartesian plane, basically understanding how to read your x and y coordinates, and using position sensing to basically decide where your robot's going to stop. Simple. And while you already know how to use your while loops, your next task is basically using the while loop, forming inequalities. You're going to draw a square spiral. All right, this is going to be slightly harder, so your inequalities would need to be slightly more complex. Okay, and you'd have repeat loops, you'd have variable, you need to set a variable. Okay, now just to give you a clue, so you're moving in a square spiral. Okay, now observe that this length and this length is the same. So you got two lengths that are the same. There's a turn here, and once you go here, okay, then it actually, the length becomes shorter. All right, so the distance from this edge increases, and this is the same as this, and then again it, this distance increases again, so it actually drives drives um, drives ahead for lesser. All right, then this one again, so it's basically two lengths, and then the next length shorter, next length shorter, and then shorter, shorter, shorter. Eventually what I want you to do, once it reaches the center, it should stop. Again, you got to use a bit of coordinate geometry. So what is that position when I want it to stop? So while it's not there, it should do that. And again, you got to use variables. Okay, you got to have a bit of repeat loop, because obviously there's a pattern here. I talked about the pattern and the lengths. So repeat loop, use variables. While operator, you need your, you need your while loop, you need your operators, your inequalities. Okay, all the best. Not that difficult once you actually realize how to do it. Thank you very much for listening. Okay, we'll talk about the solution in the next tutorial.